So it's very important to understand the difference between weather and climate. So weather is the short-term conditions of the atmosphere, while climate, on the other hand, is the average weather conditions over an extended period of time in a particular place over several decades or longer. So here's an activity to brainstorm the factors that shape climate. So I encourage you to take some notes and then pause this video and then resume it when you're done jotting down some of your ideas. So now we'll take a look at these 4 factors and you can see if you've predicted it as written here. So we see that the first factor is latitude, and so that determines the amount of solar radiation on the surface of the Earth. And we know that the poles have less solar radiation, so then these places have colder climates. And secondly is elevation. So higher elevation means lower temperatures, and you probably notice this if you climb up a hill or mountain and the temperature up there is colder than below. And then there are the features of the terrain. So firstly, there's the rain shadow effect. So that's when the mountains block precipitation. And then there's also the proximity to water. So being closer to water means more mediated temperatures and more precipitation. And the fourth point, we got to consider the wind and ocean currents. So how do we describe climate? There are 2 main metrics we use. So the mean annual temperature and the mean annual precipitation. So if you look at these maps of the US, here's an activity for you. So what differences and patterns do you notice in these maps of the US? So you can take a moment also again to pause the video and jot down what you see between from these 2 maps, and you can resume the video when you're ready. So looking at the answers to this activity, so we can see that temperature is dependent on latitude, where it's colder in the north of the country than the south, and precipitation is dependent on distance from the coast. But then also there are many local effects, and the things listed here are general patterns. So for example, you can see in Southern California there's a bit of an anomaly where Southern California is beside the Pacific Ocean, but then due to certain wind currents and mountain ranges, that area is very dry. So now looking at the Köppen climate classification. And so you can see here that climate zones are delineated by biomes. And so this classification associates temperature and precipitation with vegetation. And you can see it's a combination of 3 letters. So for example, Toronto is in zone DFB, around here on the map, and that represents a warm, humid continental climate. And so next we'll look at how to represent climate using climatographs. So this is a plot of monthly temperature and precipitation. So you can see that precipitation is on the left axis here. On the right axis, there's temperature. So here's a bit of a quiz for you with the climatographs. So match these graphs with the following map. And oh yeah, ABCD is 1, 2, 3, 4. And so we will take a look at this, and right after you pause the video, think about it, and then resume the video. Okay, so the solution to activity. So see if what you've jotted down earlier matches what the climatograph of the area is. So the next concept to learn is the ENSO cycle. So ENSO stands for the El Niño Southern Oscillation. And so El Niño and El Niña and La Niña are the opposite phases of the ENSO cycle. And so the cycle describes the convective loop of the southeast trade winds. And phases last for about 9 to 12 months. Frequency is about 2 to 7 years, with the El Niño being more frequent than the La Niña. So to describe the El Nino, that's when the trade winds are weaker than normal. So this pushes warm ocean water towards the west coast of South America, as you can see on this map. And the climate impacts are listed here on this map. And it's super interesting to see how this Pacific Ocean cycle happening in the Pacific Ocean can affect climate all over the world. And then La Nina is when the trade winds are stronger than normal and the warm water is pushed towards Southeast Asia. And you can see it's the opposite of El Nino, and the impacts are also different.